Today we're going to talk about the binary number system and the decimal number system. But to begin, we need to know a few vocabulary words. We need to know bit, byte, base, and exponent. Bit and byte come from our computer knowledge. A bit is equal to a single pulse in the digital decoding system. A byte contains 8 bits of information. And then base and exponent come from a math class where it is a number raised to a power, something like 2 to the 5th power. The 2 would be the base, and the 5 would be the exponent. And the binary number system is derived from base 2. In base 2, there are only 2 numerical options, like 0 and 1. The computer receives these as off and on, respectively. Using this information, we can build a conversion table similar to the one utilized in base 10 numbering system. Base 10, or decimal numbering system, is because there are 10 different options for digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In the binary system, it is derived off of a base 2, where there's only 2 possible 0 and 1 as digits. Our regular numbering system, if we talk about place values, you understand the ones place of a number, the tens place of a number, hundreds place, thousands place, and so on, right? Well, those place values have been derived because there's 10 possible digits, and then it's 10 to the 0, 10 to the first, 10 to the second, 10 to the third, and that's what creates your different place values in the base 10 numbering system. In the binary numbering system, there's only 2 possible digits, 0 and 1, remember? So we go to create the place values, we go 2 to the 0, 2 to the first, 2 to the second, to the third, to the fourth, and so on, which creates these place values: 1, 2, 4, 8, 16, 32, 64, and 128. There is no 2 to the 8th power because remember our definition of a byte. A byte contains 8 pieces of information, 8 bits: 1, 2, 3, 4, 5, 6, 7, 8. So there's no next place value because we've already got to 8 bits of information. So our first example of how to convert the decimal number, a regular base 10 number of 231, into a binary number, you use this place value chart, or can use this place value chart. And you ask yourself, from 231, can we subtract 128 from it? Yes, we can. So we say yes. And we're going to grab our calculators, and we're going to say 231 minus 128. That leaves me with 103 on my calculator. I hope you guys are following along with this so that you can understand what I'm doing. Can we subtract from our 103 that's in the calculator, can we subtract 64? Yes, we can. So we're going to put a 1 there and then actually do it on our calculator. That leaves me with 39 on my calculator. So can I subtract the next place value, the 32? Yes, I can. So I'm going to go ahead and do that, and I'm going to put a 1 right there. Leaves me on my calculator with the number 7. So from 7, could I subtract 16? No. From 7, could I subtract the 8? No. From 7, could I subtract 4? Yes, I can. So I'm going to do it on my calculator, and I'm going to put a 1 there in my spot. That leaves me with 3 in the calculator, and I would be able to subtract both of these last 2 out of there. So the binary number 111,00111 would represent the number 231 in base 10. To go backwards to prove ourselves that we're right, we take all of these numbers where we have placed a 1 and we add those together. So we would add 128, 64, 32, 4, 2, and 1, and it should get us back to 231 where we started. Let's try another example. So doing the same process, we start with 201 and we say, can we subtract 128 from that? Yes, we can. And I'm going to go ahead and do it on the calculator. And you get 73. So from 73, can we subtract the 64? Yes. That leaves me with 9 on my calculator. So from 9, could I subtract 32? No. Could I subtract 16? No. Could I subtract 9 minus 8? Yes. So I'm going to go ahead and do that. That leaves me with 1 on my calculator. So I would not be able to subtract the 4 or the 2, but I could do the last one. So to go, that's binary. To go back to the base 10 number, I would take all of those place values where I had a 1 positioned, and I would add those all back together. So the third example, let's look at that. 122. Can you subtract 128 from that? No. Can you subtract 64? Yes, we can. So we're going to go ahead and do it. We put a 1 there. I got 58. So yes, I could subtract the 32. I got 26 on my calculator. I can subtract the next one. Leaves me with 10. I could subtract an 8. And then I would also be able to subtract the 2 out of there. And if I wanted to go back, I would add them all together. For the fourth example, I'd like you to pause the video for a minute or two and go ahead and try it on your own. And we'll come back together and see if we've gotten the same answers. All right, did you pause the video? So for 56, you would not be able to subtract these upper ones, but you can subtract the other ones here in the middle, 32, 16, and 8. And it would get you back to 56. I hope this helps you understand binary and decimal conversion and where the binary system has come from. I would like you to stop here. Actually, the video is over. I don't know why I'm saying that. But go to the next part of the Google assignment and answer the questions on the Google quiz.